Do you have enough? Okay. I got extras. Okay. To, Today and tomorrow, we're doing 5-3, day 1 and day 2. Friday, you have one AP question, just one of them, and you're doing section 5.3, day 3. Then on Monday, we're going to practice with some more AP problems because the more you do, the better you get at this. And then Tuesday, you have a quiz, a regular kind of quiz, 5-1, 5-2, and 5-5, which is area of trapezoids. Now, your quiz on Friday is only 5-1, 5-2. So your test, we're getting there. Then we're going to do one of the most important theorems in calculus on Wednesday and Thursday. One is kind of easy. The other one's not. You find it hard. It's really easy. And then we have 3 days of AP review. And I will be gone on Monday. No, I won't. I'll be gone on Tuesday the 12th. I said Monday the 11th, but I'll be gone Tuesday the 12th. And then we have, I'm sorry about that. It's just what my plans are. The 13th and 14th, we are doing the test. And then on Friday, because that's a half day, we'll have work time. And that's also the day when you buy your way out of class.
Oh,
Yeah, we have that going on. So we'll finish chapter 5 on Valentine's Day and start chapter 6. What is 6? Oh, yeah. And then 7. So we only have 2 more chapters left. Okay, are you ready? Let's look at these problems and let's see if we can get this done in the hour. These are properties, and honestly, I've already talked about these. Okay, Declan? How does, now, just to make things look simpler, okay, guys, I'm not going to put in f of x dx unless I need it. But this really means, what does that mean?
it starts with A.
What's it?
The function
It's the signed
area.
area. Okay, all of us, we should be 100% that an integral is an area, and it has a sign to it, though, under f of x, under the curve.
Like that.
That's one thing you need to know. So when you see that little S curve, it's called an integral symbol, you'll say, oh, I just want the area under the curve. We can find that with geometry, Max, or with calculus. Tomorrow we'll do the calculus. Sort of. Really, 5-4 is where I do the calculus. Okay? Okay, Jacob? Zach?
Okay, so this is the last unit that we have to A to
No, we have chapter 6 and 7, but they're short.
Oh, okay.
Okay. So when I see this, the integral from b to a, how does that relate the integral from a to b? It's the negative. Guess what? That's your first property down here. Well, we already knew that because we talked about it. What about the integral from a to a? That would be the area under a single point, which is infinitesimally small. So small, you can't really see the point. We draw it so you can see the point, so we know it's there. But it really isn't that big. What's the area under something that basically has a base of 0? It's 0. Area is base times height. It has a height, but its base is so small, it's 0. So that's that property. I guarantee that you will see both of those properties on the exam. Well, you see them all, but those you'll see maybe a couple times even on the exam. And then we already talked about this. What if you have a constant times the function? You can pull the constant out, just like derivatives. So there's nothing, but integral is going to be related to derivatives. So that's nothing new either. Plus, and I talked about this informally, if you have the integral of f plus the integral of g with the same limits of integration, then you can distribute that or undistribute it. It's a v of f plus g. These are the same thing. Same thing with subtraction. Now, the additivity, because we can just distribute integrals. And you can't distribute everything all the time, but I can with integrals. This is saying if I have the area from a to b under f of x, there's a to b, so I have this area, and then I have the area from b to c, couldn't I just find the area from a to c? Yeah, that's all that says. That you can add the area from a to b and A and B to C. There's no overlap there, so that's equal to the same as just finding the area from A to C. That's all that says. Is that okay? Okay. The next two we're going to do on the next sheet because they take a little bit of space. And actually, number 6 relates to the mean value theorem. Okay, ready? We're going to turn the page. And we're going to explain these. Now, when you just look at this, they look terrible. But when you think about what they say, they're not that bad. Now, 6 looks really bad, doesn't it? It's kind of scary looking. So we'll do the max min inequality. I think I'll leave that there. And I'm going to take a function. It doesn't matter what function I have. There's A, and there's B, and there's f of x. And all this is saying, if I want to find the area from A to B, let's see, I don't want that. If I want to find this area, so that's the integral from A to B of f of x dx. Well, it's bounded. I can draw in this little rectangle. And let's say the y-coordinate here is little m. I'm going to do it a little differently than, I mean, it's the same as before. It's the minimum value of the function on that interval. And what's true about the area of the yellow shaded region compared to the the red shaded region? The yellow is bigger. So I'm going to get an inequality. That's bigger than, what is that area? What is that area? How do you find it? It's the height times what? B minus A. Is that okay? So I know the actual area is bigger than that area, that rectangle. And if I know where this point is and this point is, I can find that. That's easy. But what else? What if I take this rectangle? What if I take the maximum value of my function? I'll call it capital M. What's true about the yellow region compared to the blue area of the blue rectangle? It's smaller than that, right? So it's capital M times B minus A. And that's the max-min inequality. Yes, if I do it geometrically, it doesn't look so bad. If I put some numbers in here, I say m is equal to 2, capital M is equal to 5, and let's make this distance 3. How big is the red rectangle? What's the area of this guy? So it's 3 times 2. It's going to be less than, I'm going to use ditto marks to save time. And then, how big is this rectangle? What's the area for that? 5 times 3. So that if I use my calculator, for instance, and I integrate this, and I got an area of 30, especially if you're doing trig and you're in the wrong mode. You got to be in radians. So everything gets messed up if you're not in radians. I should, on my calculator, find an answer that's bigger than 6, but smaller than 15. And if I come up with 30, that tells me something. I did it wrong. Something's wrong. Okay. And I am going to actually take a little jump and go right from there to the mean value theorem. I'm going to take a picture of this, or copy it. I'm going to try. Oh, no, I'm going to take a picture. And we'll add it to a, whoopsie. Well, it's just, oh, I don't know. Yeah, but look, it's got those lines in it. That's okay. Well, I want to go to the mean value theorem because it's just kind of saying it fits here better than when I did in the second hour, I think. It is on the third page, bottom. Because then things are going to come and make a little more sense when I do the other stuff. And you have the back to write on. And I don't even like the way they say the mean value theorem. Now, this is one of those theorems. We have the intermediate value theorem. We have the mean value theorem for derivatives. This is the mean value theorem for integrals. It's going to be the same It's a little bit different form. The integral version is different than the derivative version, and I can't pull it all together yet, but it took me 2 years to figure out that they were the same thing. We have to go through section 5.4 before I can pull it together. Okay, take this picture. Now, you know that the area is between the area of the big rectangle and the little rectangle. Do you believe that the area, if you were to make all these other rectangles in here, that that area is continuous? Is that a continuous function? Yes, it's not going to jump from 2 to 5 or something. Okay, Jack? So if this area, the real area, is bigger than 2 but smaller than, whatever it was, bigger than 6 and 15, don't you think that there's some place in here where the area of this green rectangle is exactly equal to the area under the curve? There's got to be. Doesn't it make sense? Well, let's call this x-coordinate here where it comes down here C. Then what's the y-coordinate? It's f of C. So what's the area of my green rectangle? It's going to be the width, which is b minus a, which is 3 in this particular case, times the height, which is f of c. That has to equal the integral from a to b of f of x dx. Does that make sense? That there has to be one rectangle, the base of the rectangle is b minus a, the height will be the value of the function at some x-coordinate in that interval, and there's got to be one rectangle where the area of that rectangle is exactly equal to the area under the curve from A to B. You don't have to know that, but I think it helps in terms of remembering. So if I solve this equation for f of c by dividing by b minus a, this is the mean value theorem. I should have written b minus a, thank you. From a to b of f of x dx divided by b minus a. That's the mean value theorem for integrals. When I do section 5.4, I can come back and show you how it's the same as the mean value theorem for derivatives. So I don't think you want me to take time today to show you the mean value theorem for derivatives, because I'm sure you've forgotten it. Am I correct? Another way to write this, which is exactly the same way, but it bothers you, is to say f of c is equal to 1 over b minus a times this integral from a to b of f of x dx. Just another way to write it. These are the same. Okay, very important theorem. You will see it on the exam. Guaranteed. It has another name. It's called an average value of the function. This is the average y-coordinate of f of x. I'm kind of doing it in a little different order than what's on your handout. Even though I wrote it, I didn't like it. Well, what do you mean by the average value of a function? And while we're here, what is an average rate of change? Because guess what? They sound the same to me. And I've been doing this for 20 years, and they still sound the same to me. What is an average rate of change? You should always know rate of change is a what? Well, it's true. Rate of change is a slope. That's what slope is. Rate means ratio. So this is the slope. So what's the average slope, average rate of change on an interval? It's f of b minus f of a all over b minus a. That's your average rate of change of your function. This is not the average rate of change, but the average value of the function. Not the same thing. How would you find the average of all the y values, if you could? If I wanted to average all the y values, let's say I had this. Could I average those y values? What would I do with them? You would add them up. Whoops. Sorry. Y1 plus y2 plus y3 yn, or f of x, whichever you want to call it, and you would divide by n. Well, this is the same thing. Let me show you why it's the same thing. I have to use a Riemann sum. So I'm going to go back to my f of c is equal to the integral from a to b of f of x dx all over b minus a. Okay, you remember the Riemann sum. Remember when you found the area under the curve, a Riemann sum is just finding the areas of all the rectangles. And so we took this, A, and this is B, and we divided it into a certain number of rectangles. Let's call it N. How big is the base for each one of these, assuming we do them all the same? Well, if this is 3 and this is 5, and I want to divide it into 4 rectangles, what would you do? It's 0.5. Why? Because you took 5 minus 3 and you divided by 4. Well, now let's go back to the abstract. It's going to be 5 minus 3. Well, that's just b minus a. And we're going to divide by an unknown number of rectangles, call it n. That's the value of the base. This is what you're going to have to know in the multiple choice part of the exam. But we will hit on it hard in April, because if I do it now, you're not going to remember it because it's pretty hard. So we'll do it later. Okay? That's b minus a is equal to, over n is equal to delta x. Could I solve for b minus a? That's n times delta x. Guess what I could do with this? I could substitute this in for my b minus a. Well, I'm going to show you something. I want you to realize it's just adding up all the y values divided by n. So now I have, I'll just write it here because I can't see it. I have the integral from a to b of f of x dx divided by b minus a, but b minus a is n times delta x. Okay, one more step. We're almost there. Now, I don't expect you to prove it. This is a proof, but I want you to see it at least. Do you remember how we did a Riemann sum? We want to find the areas of all the rectangles. So what did we do? We added them all up. Remember this? The sigma. This is what's going to be on the exam. You will not be on your test, I don't believe. I is equal to 1 to n, and we're going to take the limit and let n go to infinity. That's called a Riemann sum. It's in your notes from 5-1. Maybe. It was last week. Okay. And Riemann says, I'm just going to take all the y values, all the heights of my rectangles, times the width of my bases, and I'm going to add them all up. That's what this means. And I'm going to put an infinite number of rectangles in there till I fill it all up. Okay, Casey? Well, he goes, I don't want to write it like that. That's painful. So after, I don't know how long it took him to say, I'm going to make up my own notation, because I have some of my own notations that I've made up for geometry. And he said, let's just call this integral symbol from a to b of f of x dx. Pardon? Riemann did. No, Casey's sleeping. Okay, let's put this in here. Now, you do need to know this. This was in the homework, 5-1, I think. When you see this limit here, it's the same as this integral. So this is equal to, no, this is equal to, let's go back and put the Riemann sum in there. It's hard. I'm not going to tell you it's easy because it's not. And it's all over n times delta x. Now, algebraically, what can cancel? Delta x. But then you have to look at this and not even worry about the limit. We only put it in there. And it's a summation of f of x sub I all over n. And what is the summation of f of x sub I? I know you're not that familiar with it. What does that mean? This means we're almost done. F of x of 1 plus f of x of 2 plus f of x of n all over n. What did I just do? I added all the y values and divided by how many I have. I just wanted to show you it's the same thing as an average value if I could find every single y value. But why can't you on this curve? There's an infinite number of points, so I can't do it. So when you integrate that, you're basically adding them all up. So what do you have to get out of this? Out of this, you have to realize this is the mean value theorem. And it's also the average value of a function. And you will see that. Now you're going to start seeing more AP problems. You will see that of a function. So we're going to be giving you lots of AP problems, and they're going to ask you for the average rate of change, which is a slope, and the average value of a function. I'm going to hit on it again and again because they sound alike. And if you're in a pressure situation on that exam, you're going to want to, you're just going to fly through it, and you're going to do the wrong one. I know. Why do I know? I'm an AP reader. I saw it. It's a lot of people integrating when they should have been just taking a regular slope. So the minute you see average, you tend to want to integrate. No, you got to read the whole thing. If it's a rate, it's always a slope or derivative. You remember rate is a derivative? If I can think of a way to connect it, I will. Okay, there's only one last thing to do here. Which, yeah. Yep. This was just my reasoning to show you why it really is an average that you add them up. Okay, Jacob? This is my reasoning to show this is an average. You add them all up and divide by how many you have. I had to do a little algebra to change this form into this form. And we didn't do these Riemann sums by hand with an infinite number of rectangles. And maybe we need to do that. Oh, it takes days. It's hard. Well, it's not hard. It's putsy. It takes days. And I want to be done with the new material before spring break. And maybe even a little before that. And we'll be more practicing with AP questions. If we were lucky enough to start a day earlier, a week earlier, we'd really be ready. But Ryan is probably going to do it. Okay. Are you ready to go back and do one problem, and then I'm going to do questions?
Let's choose multiple Wednesday. Actually, though, it's so good.
Oh, we have two problems to do. Let's do this one. Forgot about this one. Take example 2 out. In fact, I'm going to come back and do that one last. Let's do this one right here, because it's just what we just did. It says, find the average value of f of x. Well, how do you find the average value of a function? You integrate it from a to b. A is 0, b is 3, right? So we're going to integrate from 0 to 3 of this function divided by the width of the interval. So when they ask you for the average value of a function, you're just going to integrate, but you're going to divide by how wide it is. That's a simple way to think about it. Can we integrate that yet? Can we do that unless we could estimate it, but I don't know what it is. We could do it on our calculator. So now here's the mistake you make on your calculator. You write this, and then you do the integral, you forget to divide by the 3. I've seen that too. But you should earn your first point right here. Okay. That's it on that. You integrate, divide by the width of the interval. That's all there is. I know it takes a lot of talking to get there, and that's just trying to explain. So at least have seen where it comes from. So it's not a mystery. It still may be a mystery. Okay, ready to do the last problem? Oops. And we're not going to do example 2. Try this one. Try the problem. I'm going to pause for a second, let you read it. Always read your problem several times if you can. We're doing example 1 because that's what the homework is like. Yes? Oh, yeah, we'll be doing volumes. Mhm. Volumes. Volume. Finding volumes. Well, the volumes of solids. Okay. What's the answer now, you guys? Jack, what's the answer to A? No, it's not obvious. What'd you say? Was that? It's two. Why is it two? Because I really want this. Okay, this is a prime example. Well, I'll get you number a second. Okay, guys, I don't like the 4 to 1. Let's change it and make it negative because they tell me, is it two? Well, you gotta be. Let's see. It's gonna be. Is that a positive one? So I want 1 to 4. So it's the opposite of that. So it's two. Yes, these should be easy. But you want to become familiar with this so when you see it on the exam, you don't have to sit and stop and think. You want it to be automatic. What's now this one? Okay, Jack thinks it's 3 because you added the area from -1 to 1. That gets me from. Now, by the way, just because f of x is positive doesn't mean that f of x is always positive. It could have been this. And that's 1. So you could have had, yes, you did. You could have had a little bit under the graph, but more is above the graph than below the graph. So that, I'm going to add that up, plus then was 1, 2, 4. And again, it doesn't have to all be under the graph. Some could be above. So it's the integral from 1 to 4. I know. When you do the work, it's actually easy. When you take the test, and it's the first time you've seen something like that, it's hard because you got to figure it out. What about this one? 2 times the integral from -1 to 1 of f plus, I don't remember the answer, of h. So it's 2, yeah, I think it is 31. F is what, 5? And 3 times h is 7. By the way, if it's free response, I would leave it. I would not waste my time. Well, actually, they're not difficult. I like them. What's wrong with D? You can't do it. Not enough information. If they had done something with even or odd, then that's a possibility. You would have had enough information, but right now we don't. What's E? All I know, whoops, that was not the plan. But do you know what it is? No. Because of this, guess what? Not enough information. Blackboard magic. What about this one? Well, you could. Sorry. So I want to leave that up here. No, you don't. You don't. Because you have -1 to 4 of f plus -1 to 4 of h. And even though I can do -1 to 4 of f, which was 3, what is this? I don't know. Because we did it in part B. Not enough information. Tomorrow is not, well, it might be as long. I don't know. What is that? Are there questions out of the homework? Now, I'm here tomorrow morning. It's snowing now again. So. Not hard, but. Oh, yeah, we'll get that. Are there questions out of the homework? I should be getting 5-2 today. I can get it tomorrow. I don't care. I just want you to stay up to date. Did you try 5-2? A lot of the things I just did will help you with 5-2. If you don't know what a graph looks like, change the variable to x and graph it. 5-2 is not very long. You should be done. Okay. 5-1, and some people have done 5-2. So I should have 5-1 from everyone, and 5-2 is. It'd be nice to get it today, maybe. I'm pretty much caught up. Oh, you want your quiz back? Yeah. Yeah. Yes. Hey, you put it on my desk.